Here we are going to transition and get into some of the basics of regression. And so to illustrate, we have our example from last week with the GRE quant predicting GPA. And remember, we always have the predictor on the x-axis and the outcome on the y. And we have all of our scatter of our data points. And then we have the best fitting line that goes between all those points. And that best fitting line is calculated such that it minimizes the sum of the squared distances from each of those points to the line. Now, I know that may not make total sense right now, and that's okay. We'll be coming back to that concept later. So in order to calculate that line, to think about that line, we need two basic concepts in mind. So back to our high school algebra, we have our Y-intercept, or our B0, and that just means that we want to know the value of our outcome when the predictor is set to 0. So that is the definition of the Y-intercept. Please memorize that. So it's the value of our DV, or outcome, when the predictor is set to 0. In this case, it would be the value of GPA when the GRE quant score is at 0. I realize that doesn't make sense, because who gets a GRE quant score of 0? Even on our worst day, we would not. So, but there's a workaround to that, but memorize the definition anyway, and we will come back to that. The second thing we need is the slope of the line, which is depicted by B sub xy. And that is, the definition of the slope is the change that we would expect in the outcome when we have 1 unit increase in the predictor. Okay, so the extent of the change in the outcome that we would expect for every 1 unit increase in the predictor. So in this example, it's literally how much change in GPA would we expect to see for every 1 unit increase in our GRE quant scores. Okay, so if we have a lot of change in the GPA, we would expect to see a very steep slope. So for every 1 unit increase in GRE, GPA shoots up, and that would be a very steep slope, and that would be probably a very strong correlation as well. But if we have just a tiny increase in GPA, then it would be a less steep slope. So just keep that visual in mind as we move forward. Okay, so we have our regression formula here as well. And just so you know, sometimes the best fitting line is also referred to as just the regression line. So if you hear that, you know that it's the same thing. So we have our regression equation here, and just some notation things. We have the y prime, which is the predicted value of the DV. So just to make things confusing, different stats textbooks refer to the predicted value in different ways. So they have different notation. Some of them do a y with a caret over it, and they call it y hat. Some, I think Field does it in an even different way, but I'm going to use the Keith way consistently, calling it y prime, or the predicted value of y, which is the more general term. So predicted values are for every for every data point in your data set. You're going to have a predicted value of the DV for each one. So for every value of x, you can plug in whatever the GRE score is for a particular person. We'll do this in a second, actually. But you'd plug that into x, and then you'd have the computer calculate your y-intercept and your slope, and then you get a predicted value for that score, a predicted DV value for whatever that x score is. So we have the B0, which is the y-intercept, and then we have plus, and then we have the slope, and that slope is multiplied by whichever x value you're plugging in. So literally what this formula helps us do is take any score on the predictor, and we have a predicted value that we can expect from the DV. So again, predicted values can be notated differently. They can be a y hat, they can be, I believe it was a yi, or y, I don't remember how Field does it, or a y prime. And they also can be called at least two things. It can be the predicted value of y, or it can be the expected value of y. Those things are synonymous, okay? So moving forward, it's important to get the nomenclature and know that sometimes there are two or three names for the same thing, not to be confusing at all, but that's just the way it is. And so I want you to have an idea of what they are, so at conferences when you hear one of these terms, you'll know what it is, even if it's not the one that you're most familiar with. Okay, so I have some notes at the bottom of the slide that you can take a look at your leisure as well, that just kind of recap what I have said in this part of the lecture.